Hi, I'm Lauren Saponaro, and this is my Lab 2 presentation, Motion of a Falling Object. So the purpose of this Lab 2 was to observe an object falling somewhat slowly, compare it to an observational model using Tracker, and construct two computational models that use Newton's second law, one considering and one not considering drag. And the overall results of the lab showed that the computational model that considered drag provided a more accurate prediction of the motions of the object's motion. So the concepts that were used in this lab were Newton's second law, momentum, the velocity update formula, the position update formula, gravitational force, and drag force. So this is the initial video that I used. We used a crumpled piece of paper and dropped it against a ruler.
Yeah.
And I put this into Tracker to get some of the data, and this was the initial graph with that data of the piece of paper's position over time. And then, so when it came to the computational models, on the left, this one considers just gravity, and on the right is the model that considers drag as well. And for both of them, I put in the system mass of a standard piece of paper, which is 0.005 kilograms. And additionally, I put in the initial conditions for the position and velocity as both being 0, and set the acceleration due to gravity at 9.8. But the way that these two codes differ is that the proportionality constant to consider drag was set at 0.2, b equals 0.2. And then for no drag, it was just 0. And then continuing on with the computational models, for the one that does not consider drag, the net force is just equal to weight. So I plugged in the equation for weight. And for the model that considers drag, I plugged in the drag formula. And for both of them, I updated the position and velocity using Newton's second law. And the codes differ at the bottom, where for the drag computational model, I needed to add in arrows to represent the forces. So I added in an arrow for weight and an arrow for drag. And then here is the graph that shows the computational versus the observational model. And as you can see, the motion of the computational model considering drag is much closer to the observational model than it is to the computational model that just considered gravity. So the one considering drag was more realistic. And what does this mean? It means the computational model with drag predicts a terminal velocity for the object, while the model that does not consider drag continues to accelerate at a constant rate. So these were the two graphs that came out of the code. And you can see that drag is like a more accurate representation than just like the constant rate that no drag has. And so like, what if, like, imagine that the object was initially thrown downwards, would the terminal velocity in this case be the same or different from the case where the same object was initially dropped from the rest? And basically, no, the terminal velocity would not change. And this is because even with a different initial velocity, terminal velocity would still be reached, just in a different amount of time than that of an initial velocity of 0. And yeah, that pretty much sums it up.